Good morning. So today, we are going to add the real-life application of mathematics in terms of understanding the limits. The title of our roleplay is Exploring Limits, a bridge to real-world understanding. In the heart of every structure, from towering skyscrapers to humble bridges, lies the essence of mathematics. Today, we embark on a journey to understand one of the fundamental concepts in calculus, limits. Join us as we explore how limits shape the every foundations of our world.
Good morning, class.
Good morning, teacher.
Class, today we're diving into the world of limits. Imagine you're driving across this bridge. What happens as you approach each stage? Can you predict how close you can get without falling off?
Well, I guess there's a point I can go any further without falling, guys.
Exactly. That's the concept of a limit. In mathematics, we use limits to understand what happens as we get closer and closer to a certain point. Let's delve deeper into this idea.
Just like our bridge analogy, limits help us understand what happens as we approach a certain value, whether it's calculating the speed of a moving object or determining the continuity of a function. Limits are essential tools in a various real-world scenarios.
When designing bridges, understanding limits is crucial. We need to ensure that the materials can withstand the forces acting upon them, even at extreme conditions. By analyzing limits, we can guarantee the safety and stability of our structure.
In medicine, limits play a vital role in understanding the behavior of biological systems. For instance, when studying the growth of tumors, we use limits to predict how the size of tumors changes. Over time, this knowledge is invaluable in developing effective treatment strategies.
So, the next time you cross a bridge or ponder the mysteries of nature, remember the humble concept of limits, a bridge between theory and reality.
Hello, engineer. Hello, how can I assist you today? We're planning to build a bridge over a river, and we need to know the maximum weight it can safely hold.
Alright, to determine that, we'll need to evaluate the limit of the load capacity function as it approaches various points of stress.
Sounds complex. How does that work?
Well, let's say the load capacity function is represented as f of x, where x represents the distance from one end of the bridge. We'll analyze fx as x approaches critical points, such as the center of the bridge.
Why the center specifically?
Typically, the center experiences the highest stress since it is the furthest point from both supports. By evaluating the limits as x approaches the center, we can determine the maximum safe load the bridge can bear without collapsing.
Ah, I see. So, how do you calculate the limit?
We utilize mathematical techniques such as calculus to evaluate the limit. By considering factors like the material strength, bridge design, and environmental conditions, we can derive an equation for f of x and then use calculate to find its maximum safe load.
That makes sense. So, once you find the limit, we'll know the maximum weight the bridge can withstand.
Exactly. Knowing this limit ensures the bridge structural integrity and safety under various loading conditions.
Great! Thank you for explaining. I feel so much confident about the project.
You're welcome. If you need anything further question or need assistance with anything else, Feel free to reach me out.
Will do. Thanks again.
Have a wonderful day.